All right, welcome everybody at Onward. My name is Thijs van der Storm. I was the PC chair for papers, and I've basically run Onward together with Robert Hirschveld over there. He did the essays track. I'll be giving a very brief intro to what we have done to compile our fantastic program, if I say so myself, just like Mira just did for UPSLA. Of course, the numbers are slightly different if you looked at these numbers she showed. So we had a quite standard review process. Both essays and papers were reviewed by at least 3 reviews, and then we're giving a conditional accept or reject notification. We had intensive discussions in the online PC meeting, really influencing the final decision to accept a paper or an essay. And in the end, this resulted in, for the papers track, in 9 papers to get accepted out of 19 submissions. And the essays track received 6 essays, and 4 of those were accepted. This was all due to the hard work of our respective program committees and a number of external reviewers. So I would like to thank all the reviewers for their hard work with a round of applause. So, and then, this has led to a program that roughly looks as follows. We are starting today with a keynote, the Onward keynote by Felienne. And then there are sessions in this room, roughly thematically organized. So 2 sessions with papers, and then the last session with essays. And we have a half program tomorrow with 3 more papers and 2 more essays. So also please come here tomorrow to enjoy those talks. So before I introduce Felienne, I would like to reinstate an old tradition of Onward that was for some reason skipped a couple of years, and that is the Onward Most Notable Paper Award. This is a sort of best paper award, but 10 years after. And since this is Onward, this is not about the best paper in any kind of hard sense, right? It's the most notable paper. So what is interesting, what is weird about it? And I'm very happy to report that this year's Most Notable Paper Award goes to Usable Live Programming by Sean McDermott. He could not be here, but if you know this paper, it's really very notable, and I want to read a little text about it that was compiled by the steering committee. This paper revitalized the study of live programming, introducing mechanisms that are now standard techniques in the field. The paper epitomizes the spirit of Onward, asking risky questions outside the current discourse, and in its form, the paper was a breath of fresh air, enlivened by the use of comic strips. The work marked the beginning of a rich theme of research that has been productively mined at the ongoing live workshop series at Splash, which was last Monday. So to give you an example of how this, why this is notable, or at least one aspect why it's notable, is that it contains these comic strips hand-drawn about, programming experience things and how live programming could help this. So big applause for Sean McDermott. All right, so then this leaves me with the happy task to introduce our speaker, keynote speaker today. Note this is a combined keynote by from Splash E and Onward, because Splash E is computer science education, and this is one of the topics that Felienne is working on. So she is a full professor at the Free University of Amsterdam in a sort of dual chair with computer science and computer science education. She obtained her PhD from Delft University with Arie van Deursen, bringing software engineering techniques to spreadsheets, winning multiple best paper awards already during her PhD. She wrote a book on the programmer's brain. You see it over there. And she is also at the table of TC39 monitoring and guiding the evolution of JavaScript. In the meantime, she also teaches programming at the high school in Rotterdam. She is the designer and maintainer of the Hedy programming language, which we will hear about more. In 2021, she won the Dutch National ICT Prize, which is awarded every year to recognize excellence in computer science. She is a well-known speaker in both academic and developer practitioner conferences, also recognizable from her signature handwritten slides, which I hope we will see a lot of them. If that's not enough, she also writes columns for developer magazines or on the radio, and basically she's an all-round good person fighting for more inclusivity in programming and research. So, without further ado, Felienne, thank you.
Yes, this is working. Not so inclusive of small people. Maybe this is better. Let me move a bit so I can see the room. Good morning, everyone. So my name is Felienne Hermans. I'm a full professor at the VU in Amsterdam. My chair is in two departments, so partly it is in computer science and partly it is in the educational department because my research sort of combines those two things. And I want to talk today about creating a programming language for humans, for people. And I want to take you back into my personal story of designing the Hedy programming language and all the things that I've encountered in that, story of a few years. So one of the things I really very much believe in is that everyone needs to have some programming skills. Not everyone needs to be a programmer, even though there's also a shortage of programmers, but everyone needs a little bit of programming skills. Just like we say, everyone in our society needs to have writing skills. Not because everyone needs to be Agatha Christie, but because everyone needs to be able to write a poem, or graffiti, or a love letter, or a pamphlet. Right? These skills are needed to participate in society in a valuable way, and in the same way, everyone needs a little bit of programming skills so that they can do data analysis about things that they care about or about in their jobs. Programming skills are important. And to me, they're so important that actually a long time ago, about 10 years ago, I started to teach in a high school. And in my country, high schools are a little bit different, so I'm teaching 12-year-olds because that's for us the beginning of high school. This was also, by the way, there's other stories to be told about this, that this was when I was sort of in the middle of my tenure track as an assistant professor, and I was not so happy with academia. I was sort of almost burned out. I thought I want to do something of value, and if I teach in a school, then this will also be of value. And I thought, okay, this is going to be great, right? I'm going to teach 12-year-olds programming, which is going to be easy because I know everything about programming. Like I have a PhD in programming, so this is going to be easy. They're 12-year-olds. Their questions will be easy. I will answer the questions. They will be impressed. They will learn. Yay! And then what happened, not explicitly, but subconsciously, I remembered how I learned programming when I was a kid. So this is me when I was a 10-year-old behind my dad's big computer. Well, actually, the big thing was a monitor, and somewhere there was also a computer. And I was learning programming when I was about 10. But in those days, there weren't programming clubs or programming lessons. I didn't know any adults close that knew programming. So I didn't have a programming lesson. What I did have was this. A book, Basic Computer Games. I see some people nodding in the audience. So this was a book that was allegedly going to help me make games, which I was excited about. There was no Steam, right? There was no internet, no Xbox. So if I wanted to make a game, this is how I would make a game. And this book was not a book that would teach me how programming works. It wasn't like, this is a variable and this is a loop. If you would open the book, it would be this. Printed out source code. And maybe young people in the audience would be like, wasn't there a download link? Wasn't there a CD-ROM? No, there were none of these things. You would just manually copy this into the computer, and if you can read really well, you can see that this is even in English, which is not my first language, so it has words like velocity. I have no clue what I'm doing, but there's no Steam and no Xbox, so what else am I going to do with my time? So you just copy this into the computer, and then sometimes you would make a mistake, and then the computer would be really helpful with tips like syntax error. Or expected comma or semicolon or end of statement. Remember, I am 10, I do not know English. I have no clue. But ultimately, of course, I did learn something. I figured out many things, and one of the things I figured out is I like this. Right? I like to make stuff, even though it's sort of painful. So as I said, I saw some people nodding in the audience who would say that this was also generally their experience in learning programming. Yes, so quite a few people. Yeah. So the sad news for you and me and all of us is that in this process we have occurred maybe some mental damage, right? Because we have come to believe that compilers are lovely teachers. We think that because this is the way we learn, that this is the way learning is good. Like this is a good way of learning. It's like we have no friends, right? So it's like we start to identify with this compiler, even though it keeps shouting. It's like, oh, you are my friend, compiler, even though you're mean, because I have no other way of learning. This was definitely the way I was thinking when I started teaching. And again, not explicitly, but implicitly I thought, well, I will just give the kids programming booklets. They will copy them into the computer. If there is a mistake, they will not be sad and frustrated. They will just plow on like I did when I was their age, and everything will be fine. So just to give you a little bit more context about the programming club. Initially, we started not with textual languages, but with visual languages like this, like Scratch. I guess many people are aware of the visual language Scratch. This actually worked really well because Scratch doesn't have syntax errors. It hardly ever shouts at you. So this was quite a good way to get started. But as these 12-year-olds were aging a little bit, they started to say, this is for kids, right? This is a toy language. And specifically the part of the Netherlands where I teach is very much what you would call in America an inner city neighborhood, where kids are also very motivated to do programming because it will get them good jobs. And then if you see this doesn't look like something that would get you a good job, even though the skills might. It doesn't look like the type of thing they're looking for. So I said, don't worry kids, we're going to do Python. Python is a very easy to learn, very user-friendly language. This is going to be a breeze. Don't worry, this is Python. Look, this is Python, so you just put a text there, a print, and brackets, and quotes, and then if you execute that, you'll have text on a screen. I was very excited by text on the screen when I was 10. So I was like, that seems like a lot of work to have text on a screen, right? There's quite some things you have to know. And of course, sometimes kids make mistakes, like this. They accidentally put an uppercase P in the word print. Then, does Python understand this? Is Python like, no biggie, I know what you know. No, it says, name error, name print is not defined. And this, you see some tension where kids don't understand what a computer can do, right? It can multiply 17 and 341 in 1 second. And if you ask it, who was the emperor of Rome in 300, then it will know, but then it cannot fix this. This doesn't fit what computers can do, right? Once you're in the world of programming, computers can do nothing for you, basically, but everywhere else, more and more, computers are sometimes quite helpful. So there's like, yeah, a computer is really precise, but then they're working with ChatGPT, and then the computer doesn't have to be very precise, all of a sudden. Here's another one. A kid has just forgotten the final closing bracket, right? It's very clear what this program is meant to do for any human. And then the computer says, syntax error, unexpected EOF while parsing. So the kid is like, teacher, what is parsing? It's like, don't worry, kid, I have the dragon book right here. Like, I don't want to talk about parsing. Like, I want to talk about parsing, but not to a 10-year-old in the first lesson, right? They don't want me talking about parsing. So you see these programming concepts, they jump into your room, into your classroom, and you cannot keep them out. Here's another one. So this kid is like, teacher, I've learned from my mistakes. Everything is perfect. This is the perfect program. It has quotes. It has brackets. Everything is there. Including this thing, a space, like literally an invisible error. How can Python not compile this? How can it not just ignore this error if there's not any indentation? It would be trivial to just run this. But of course it doesn't. Indentation error, unexpected indent. teacher, what is indentation? Like, I don't want to talk about these things. And then you get into the situation, if you're a teacher, where either you have to explain what indentation is and why the computer doesn't do this, which is not going to be so interesting, or you have to say, which I also hate, just remove the space because I tell you to, because the computer tells you to. And then I want to go like to the bathroom and wash my mouth with soap, right? I don't want to say to kids, I cannot tell you the answer right now. I really believe that at every level you should be able to clearly explain everything to everyone. And then this, I cannot explain this in words they know, and the only solution I have is like, just do it. So this is more or less the situation of my programming classes after the first few years. Not so many kids were so interested in continuing with my lessons. One of the kids actually came up to me after a few months, took the book and sort of dumped it on the table and said, I'm never coming back to your stupid programming class. But it was useful feedback, like it helped me shape my career. But to be honest, not everyone left. Actually, there were a few kids in every generation, like tiny Felines, that were actually interested in pursuing this. But after a while, I realized almost always they're boys. And why is this the case? Like, you could say, well, boys have more stamina and motivation. Like, that is maybe a reason. But I think one of the things that I also saw is that girls in my classroom would typically always come in with very low self-confidence because they have already grown up in society if they're 12 for, let's say, 10 years or 6 years, where people were telling them programming is hard. Programming is going to be hard. Programming is not for girls. Programming is not for you. I have literally had dads bring their daughters to programming club with the words, I don't think she'll like it, but. I don't actually think she'll be good at it, but. This is the society that girls grow up in. And imagine you are already a bit scared and everyone is telling you this is not for you. And the first thing you see is unexpected EOF while parsing. Then you're going to be like, well, you know, they were right. My dad was right. My brother was right. This is not for me. And I think if we talk about inclusivity in programming languages, we talk about doing fantastic things like having dinners for female grad students and professors, which is very good. We talk about role models. We talk about explicit discrimination more and more. We never talk about error messages, where I think this is also so important that if you know some parts of the population are going to have lower self-confidence, then it really, really matters what their first experience with programming is in a very different way that someone that comes in, a little boy maybe saying, oh, I'm going to be a programmer later and nothing will ever deter me, right? Then this matters a lot less. So at this point, after failing for a few years in my school, I thought, okay, this is actually an interesting research area, right? I used to research end-user programming in spreadsheets before. I thought, this is actually interesting. How do people learn? How do you get that syntax into your brain? How does this not become frustrating? And I started to read a lot about educational theories, not about computer science education, but specifically writing education. Just really, really diving into this world of how do people learn stuff. And this was in the middle of my tenure track. So this was not smart. If you look me up on Google Scholar, you see this dip like around 17, 18, where I just have not so many papers because I was learning together with people that actually know a lot from education. And this was not an easy stretch of my career because it's really very hard in the academic system that we've created together to say, I need to learn. I cannot produce anything now because I'm learning. And then sometimes I was telling myself, don't worry, thinking is your job if you're a professor. You are learning, you're thinking, this is going the right way. But of course there were also days where I was like, I'm an absolute failure. They should have never hired me. This career is not going to go anywhere because I'm not producing anything, which of course is very much a perspective on academia that producing is success or that knowledge is paper writing, but this is the dominant thinking. So this was not a great part of my life actually, because I thought, I feel that I'm doing something valuable, but the system I am in is not valuing what I'm valuing. Anyway, after a few years of not doing much, I did learn much. So one of the things I figured out is that if children learn to read, we are very, very soft with them because learning to read is very hard. So if you have a 6-year-old and they've written this, you're not going to say, syntax error, floating I. Like, this is funny, but this is what we do literally, right? You're going to say, well, good job, buddy. Some of these things are letters. Here's a sticker, right? This is correct. This is not wrong. This is their level, and we're meeting them at their level. And then of the age, then the rules change. After a while, we say, oh, you know, if you have a bunch of letters, if you put them somewhat close together, they can form words and different sounds, like a little sentence, cat in tree. And they practice that in that world where this is correct. And then after a while we say, well, actually, sentences are not just groups of words. They have to start with a capital letter, and they have to end in a period. That's actually the rule, and there's stuff like articles is there. And then they practice in that world. And actually this difference going from here to here is not just a syntactic difference. It's also adding expressive power to the language. Because once you can start and end sentences, you can make sentences that span multiple lines. Whereas initially a line and a sentence for a beginning writer is just the same thing. So we're changing the syntax and also adding concepts and expressive power into the language. I thought, this is an interesting idea, where the rules slowly change in terms of syntax and the things you can do and the things that we believe are correct at that level. Programming languages could be like this. And then I sort of, from all this entire story of learning about learning and figuring out stuff, I thought, well, you know who can make a programming language? Me, right? It was like, now, this was, first it was the bad part of the Hollywood movie, and now there was the part like, I trained for this. This is my destiny of building a programming language for this. So that's what I did. The Hedy programming language, here you see a little bit of the Hedy language. This is Hedy level 1. So we start simple. You just type print, and then whatever you want. So you just high splash, and then it says high splash. It just outputs that. No brackets, no quotes, nothing, doesn't matter. What I also said in the beginning, what I saw in the school is that kids didn't really understand why they were doing this. Kids would ask me if I would show them this program, but why do I do print? I can just type the text in Word. Why do I need to put the print there to get this? Right, this program doesn't really explain what programming is for, like why you would do this. And I thought that was quite a deep question from a 10 or 12-year-old, that, yeah, you know, why am I doing this? So from the beginning, we add this idea of user interaction. So we also have this in level 1, where you can say, ask, how are you? It will give you a pop-up box. And then with echo, it will repeat the answer back to you. So this is what it will execute to. It says, how are you? It also makes it really clear that that's where the text goes. If you do this in a command line interface, then sometimes kids don't even understand where they have to type. So how are you? And then you type great, and then it will say, okay, so you are great. So there is already state, there's this idea that the computer can store this value somewhere. You don't have to access it, you don't have to give it a name. But now kids think, okay, so now I'm creating a program that is for someone. Someone is a user of my program that is maybe not me. And you can even, with that green arrow, you can remove the code from view so that you can have someone play your story or your program without them seeing the code so they don't see where it's going. So this is level 1, and kids can explore just a little bit, this is what programming is. Also the mechanics of it. I type on the left. There's a green button that I have to press to get the execution on the right. Some kids in my school, 12-year-olds, have never used a computer before. They have a tablet or a phone, but why would you go in a computer if you're a kid? The computers are for dads with emails, right? Or for your mom with video calls. They're not a thing that kids necessarily interact with. So just the mechanics of using the keyboard, clicking with the mouse, is so much easier if there's not also syntax involved. So, warning, trigger warning. Some people are really upset with the next piece of code I'm going to show you. Just if you're easily worried about things, you might want to close your eyes. Because this is level 2, and this is actually valid Hedy code. So it assigns Felienne, the value Felienne, to the variable name, and then it prints hello name. I'm waiting for the tomatoes. Some people get really angry because they're like, oh, but hello is a plain text string, but name is a variable, and now how would kids know the difference? It just works, right? And you know why? Because I parse twice, and first I collect the values of the variables, and then I put them back in the parse tree. It's actually not very hard. But for kids, this is so very useful, because I can teach them about the idea of a variable. This is the idea that there's a value that you can give a name, and then later in the program, you can actually reuse this name, and the computer will remember. And you can use it not once, but twice. It doesn't wear off or something. They can really very much focus on learning what the variable is. Whereas if you want to do this in Python, you have to do this, right? You have to do so many things. You have to use quotes around the value. You have to have prints and brackets and distinguish between a value and a variable. This is just too much for some kids. And I saw some kids struggle with this for a few weeks, just only trying to get the syntax right and never getting to the point where they were actually reasoning about what a variable is, because they were just, there are errors and the computer keeps shouting at me in red letters, so I just add symbols until it stops shouting. So this, even though some people would be like, this syntax is so weird and it makes me feel a bit itchy, it is actually very, very useful for learning. And one point that's interesting is now that I often use this, I'm also trying to see, hey, even in Python, sometimes I would be happy, maybe not in the big code base, but in a little script, I would be happy if I don't have to tell Python what the string variable value is and what the variable name is. I have to, even in Python, I have to put an F there and quotes. It knows what a variable is because it's parsing the program. Why am I doing this work telling the computer what it already knows? So this is level 4. In level 4, we introduce quotation marks. Because at one point you have to learn that, yes, there is a difference between a string value and a variable name. And because the language is so small, because we have so few concepts, it's also a lot easier to generate error messages that are more readable. For example, if you would forget a quote, then Hedy will tell you, be careful, if you ask or print something, the text should start and finish with a quotation mark. You forgot that for the text, how are you? So it's very actionable, it tells you what the mistake is and why. So this is level 4. Slowly, gradually, in 18 levels, we actually bring children to Python syntax. So our level 18 is actually functioning Python code. So from there, it is very much like trainer wheels on a bike. You put them on, and then you practice a little bit, and then at one point you're like, oh, we take off the trainer wheels. And now you have a real bike. That's how we also see Hedy, that slowly we bring you to Python, and then at the end, well, it's Python. So now you can move and live in the Python world. And this also executes. So I built this as a small prototype in one Christmas break 4 years ago, just because I wanted to try this in my own classroom. I wanted to see if I could build it, and also I wanted to see, would kids like this? Would it be better? Would it work? So this is actually my school, the name of my school, and after half a year I said, okay, let's try this in the classroom. Let's see what happens. And one of the things that I saw, and also my colleagues very much saw, is that the classroom atmosphere was just changing. It's not necessarily something you could maybe measure with a questionnaire, but we could just feel stuff being different. In the Python world, all the time, kids would be with their hands raised and frustrated. And as a teacher, I would be running around. Even as an experienced teacher, you still have to read the error message and figure out what's wrong. And in the meantime, I have 32 12-year-olds, right? So they're all shouting, and if they're not helped, then they will annoy each other. So just it takes so much energy running around in the classroom, figuring out what's wrong and what's going on. And then when we switched to Hedy, just the calm appeared in the classroom because they would get fewer error messages. But also, for the teacher, if I see an error message that is like a bracket is missing in line 4, I can just say, oh, you just have to check line 4, right? So I don't have to process a lot myself. I can just see, this is what's wrong. And also, this is something I used to do all the time. I would tell kids if there would be an error message, hey, you just read the error message. But if the error message is unexpected EOF, what is the kid going to do? A Dutch speaker that doesn't even know what those words mean. Well, probably English-speaking kids don't know what EOF means. But now I could really say, hey, just read the error message again and walk away in confidence that I have given them a helpful tip. So it really, really, really changed our perspective of if you have better error messages, it's not even necessarily for the students because a lot of the time they don't read it, but for the teachers, it gets so much better if they're good because it saves you as a teacher time. And the cool thing about using your tool like all the time, every week, is also you get to see the tiniest things. Like here's one of my favorite examples where kids would say, well, teacher, we don't love these error messages. I was like, have you seen Python? I think we're actually pretty good, my child, but tell me what the issue is. So you cannot put a comma there because it confuses our parser. And I think actually our error message is quite good. It says, the code you entered is not valid. There's a mistake on line 1, position 12. This is exactly where the error is, and then it tells me what there's wrong because you cannot put a comma there. So I said, okay, read this error message aloud to me, because I think this kid has not read the error message, and this is why they're confused. So I asked the kid, read this error message to me. So the kid says, yes, line 1, position 12, you typed, but that is not allowed. So the kid's like, why can't I type? I'm typing all the time. Why can I not type? So I was like, because this is a 12-year-old. What have we told 12-year-olds for 6 years? If you see a comma, you take a little pause. So it reads, you typed. But that is not allowed. It is the most sensible thing. And of course, we have statistics, right? So I could have seen in the database that this wasn't an excellent error message. But without a kid telling me why this is confusing to them, I would have never guessed. Like this is even before level 4. So it's before I have told them that quotes mean a literal character. There's no way that they can know this. There's also another one which was exactly the same, but they didn't have the comma, but it had just a space there. So you cannot type. So the kids were like, I don't get it. It was valuable feedback. So this is what we do now, actually. Instead of having the character there, we actually vocalize all the symbols. So it says, you typed a comma. But that is not allowed, which is just, it is a tiny, tiny change. But clearly it's a lot better. What I also saw, not necessarily in my classroom, but in other teachers' classrooms, is that kids would very much struggle with what am I supposed to do? So one of the teachers in my school, in another class, the kids would say, okay, teacher, I think I know what a print is. But now, what do I do, right? What is my assignment? And I think a lot of you that raised their hand when I asked you what was your experience in learning to program were people that had many ideas of what they wanted to build, and they just wanted to put them in the computer. But there's also many people that if they start programming, they don't know what programming is. They don't really know what programming is for. They don't know what they're supposed to like. And this is also a perspective of gender. So by and large, we know from research that men and boys very often like to try out stuff. Like if you buy a new microwave, then the guy is more likely to throw away the manual and just to start pressing buttons. And women are more likely to actually want to read the manual, want to figure out what is going on, and only then start. This is like an established way that male and female people have preference in learning. So just saying something like, you don't have to write documentation because no one reads that, without you knowing, that's actually quite a gendered statement because women are way more likely to actually be interested in reading. If you know that this is a thing that exists, then if you look with that view at programming environments that we have, like a Python environment, it doesn't tell me what to do. It doesn't have a button to help me get started anywhere. Even a programming language like Scratch, sort of by design, doesn't have built-in tutorials or manuals that I can read. So if you know this, and then you look at these tools, you're like, well, they're manly, they're boyish, even if they don't have, I don't know, robots and stuff that boys might like more. Just the way the UX is designed only caters for people that want to jump right in. That's what it's for. And from this, I think I learned that tools for learning are really, really, really different from tools for teaching, right? What I was experiencing in the programming club, specifically when we're still doing Scratch, is that kids do everything. Like one kid might do this, right? Look, teacher, I made a very reasonable program. But another kid might be like, well, teacher, I have this, and I need more help. And this is just more likely to be a female student that doesn't know what's next. In the same classroom, you might also have other kids, more likely to be boys, that are like this. Look, teacher, I made this fantastic program. It's very messy. It's also very clear and very well organized. And now what I want is I want the palm tree to be blue instead of green. Now I, a person that holds a PhD in software engineering, has to be like, that's a great question. I don't know how to do that, right? I have to sit down with you and figure out what it is that you have created. And then this creates a situation in the classroom I only realized after a few years where I was always engaging with these kids because they had interesting questions. Those were the kids that had a lot of interest in program, and all my attention would go there upon reflection. And the kids that were just not so far, I didn't know how to help them. They would come to me and say, what should I build? And then I would also be like, whatever you want, which is just not helpful. So in Hedy, we have this interface in which in the UI, it tells you what you're going to do, which is very weird in programming languages for children. It's like, this is what you're going to do. Are you ready? Let's go. Go to the first step. And then you go to the first step. What we also do is we give teachers the power to customize this experience. Because if you have 30 children in your classroom, you might want to limit the distance between them. You might want to say, I want everyone in level 1 and 2. I don't want people to advance because their excitement is going to take away my energy of teaching the kids that don't have so much knowledge yet. And kids without prior knowledge is maybe more likely to be girls, but also kids that come from lower socioeconomic families where they don't have computers are just less likely to have background experience. So if you want to, as a teacher in the teacher's back end, you can customize everything for your classroom. So you can say, well, you don't see all of this, which can be a little bit overwhelming. You just see this. And then you can also upload your own lesson plans as a teacher. And then you can block off levels. So you can say, well, go to level 2, then this doesn't work because your teacher hasn't made this level available. And this allows you as a teacher to keep kids closer together, and this helps you maintain your energy. And as a teacher, this is really a feature that many, many teachers very much like about our UI, being able to customize what goes on in your classroom. Okay. So after this free-form exploration, we actually did a user study in which we asked kids, okay, how can we make Hedy better? And it's so cool to engage with your users, even if they're kids, and hear from them what they want. So then they said, the kids in my classroom, we want to program in Dutch. Which I thought was remarkable because the whole UI had always been in Dutch. All the explanations, the error messages had always been in Dutch. The only thing that wasn't Dutch was the keywords. And the kids would be like, yeah, why not also the keywords in Dutch? You made this, miss. Why don't you also make that? Like, well, because it's a lot of work. But I was actually really surprised because Dutch teenagers, I was like, well, you know, we are very good at English. Why? But then I realized that, you know, why are programming languages in English? It's a really great question. And I think one reason is because the people that know programming can already do English, or they have learned English through learning programming. So they're like, well, I don't see the problem. And also, some people object to languages in different natural languages, because then if people program in different languages, then maybe they're not able to understand each other's programs. But I built it anyway, partly also because it was a pandemic. I had a lot of free time. So we built this multilingual keywords in Dutch. And then the interesting thing is, many other people started to contribute translations. After Dutch, which is very similar to English, we also got German and French and Spanish. And the farther away we were getting from English, the more I was seeing the value. We started to get weird, from my perspective, languages like Hindi and Bengali and Chinese. I was like, wow, this is so cool. I'm so proud of myself. I'm like, yay, I built a localized programming language. But then in your life, often, if you're lucky, you have people that hold you to a higher standard. One of those people is here in the room with me. He's Aladdin Sweden, my co-author on much of this. And he's like, yeah. So, well done, Hermans. Very impressive. Those left to right languages. Well done, you. What about Arabic? I was like, my good sir, must you really? He must really, yes. And it was still the pandemic, so it really gave me this new perspective. Like, imagine you're teaching programming in Palestine, right? And you're teaching kids programming in Python, and you're like, print, and it starts with a P. And kids that grow up with Arabic, they're like, what is a P? And how does a P differ from a B and a D? It's like the same letters. I'm learning Arabic. Now I have a deep understanding of how hard it is, because all the letters are really quite similar if you don't know them. So I was like, yes, we must also have keywords in other languages. And one other argument that I didn't think about, my first argument was, no, this is about fairness, right? This is about inclusivity. But it's also about very practical things, about ergonomics even. Because if you're programming in Arabic with English keywords, or you're doing Arabic strings, which just makes a lot of sense, you have to first set your keyboard to English with a key press or a mouse click. Now you're typing in English letters the keywords, and now you have to again press a button, and then only can you type an Arabic string. So every line that you're switching between keywords and strings, or variable names, if your programming language also supports that, is an extra button press or an extra mouse click. And this is, even for professional programmers, it's like taking away your flow, right? It's very annoying, but you can imagine for beginners specifically, continuously they're frustrated about what keyboard am I in, which I think is really an amazing argument that me, a Westerner, would have never been able to come up with. So we actually had English keywords. So this is the turtle that we also have in Hedy, where you can simply just create forward and turn in Arabic keywords. So again, I'm like, well done, me. We have Arabic keywords. This is going great. That guy was like, yes. And what about Arabic numerals? It's like, Arabic numerals? These are Arabic numerals. Right? These are not Arabic numerals. I learned this at the age of 37. Maybe people younger in the audience, they learn it now. These are actually the numerals that Arabic uses. I didn't know. Fun fact about the Netherlands, all 12-year-olds in my country have to learn Roman numerals. This is in the law of my country. So we have to use Roman numerals to interact with clocks and buildings, but we don't learn Arabic numerals that are actually used in Arabic. So I thought, this is easy. This cannot be a problem. We simply put those numerals into Python, and this will work, right? It does not work. So if you add two numbers in Python, this works, of course. If you add two Arabic numerals in Python, it doesn't work. And it tells you this, invalid character. So who is Python to tell someone that their actual numerals that they grow up with are invalid characters? Right? This is quite sort of interesting. And there's actually a lot of philosophy about this. So there's a researcher, a philosopher called Miranda Fricker that has this whole book about epistemic injustice, which is the injustice about knowledge participation. So we often say as programmers that programming languages are a representation of knowledge, So who was involved in creating this knowledge? Who was involved in making decisions about these programming languages? And really, if you think about it, what problems are we solving programming? Like at this point, there are 6 robots running on Mars with software, which is like, it's amazing, right? It is fantastic that we can use software to put robots on Mars and control them, and they send images to us. It's like, wow, I wouldn't know how to build this. But in the same universe where software is everywhere, Python doesn't let me add 2 numbers, right? This is a very, very weird and large contradiction. So yeah, I know it was still the pandemic, so we also support Arabic numerals. So this is printing 2 numbers. You can add the numbers. It outputs it. This is a for loop with a loop counter that goes from 1 to 5. This also outputs it. If you want to, you can get your output also in Arabic numerals, which was, of course, it was a little bit of work to build this, but it was doable. So we're getting slowly towards the end of this talk. The thing I built, the Hedy programming language, went from something 4 years ago that I built for my own classroom, in my own school, sort of for my own enjoyment, into this massive project that is now translated in 47 different languages. We have hundreds of thousands of users. The last 2 months, we had over 1 million users on our website. Yesterday, I was sitting at breakfast with random people that I had never seen before, and they're like, yeah, we use Hedy in our Coder Dojo. It's like, yeah, this is pretty cool that so many people are leaning into this idea that localized and easy to learn programming languages are of value. So, I want to look at the future of programming. But before that, I want to look a little bit at the past, my past also in academia, in this community, because I started in PL. Maybe some of you were there and remember this, that my PhD thesis all the way in the beginning was supposed to be about building programming languages. And then when I was very young and I had cool hair, I was at eCoop in 2010. Anyone in the room that was also at eCoop 2010? This was in Slovenia. 2 people, cool. So I was also there. This was my absolute first conference, and I was working on spreadsheets. My advisor sent me there alone, so I had no clue what I was doing, and I was presenting a paper about how spreadsheets are programming tools. And no one really was explicitly mean to me. There wasn't like real harassment, but still I ended up thinking, I don't think I belong here. I don't think this is a community where I want to be. And then, when I was 25, I didn't have the words or the vocabulary to really understand why I didn't feel at home there. And some of the people in the audience have seen this talk before with a different ending. I changed the ending based on my experience over the last few days. So the last few days, I've been telling everyone, what do you work on? I work on making programming languages that are not English. And what I was ready for was the question, why? Because that question I get a lot, like, why would you do that, right? And I can explain why, because all of the things I just said, the inclusivity, the philosophy of it, the ergonomics, but that wasn't the question that people were asking me. Anyone want to do a guess what the #1 question I got over this week repeatedly about my work? How? Cool. Half points. No, surprisingly not, no. So the question I got all the time was, why is that hard? Why is that hard? This is trivial. This is just a replacement. You can do it in English, so why couldn't you do it in Chinese? Case closed, right? And I realized what was happening to me was I got really defensive. I was like, yeah, but it is really hard. It is really hard because have you heard about quotes being different in other languages? Keywords, numeral, word order, diacritics, all these things that are really hard. If you're interested in knowing all these things that are really hard, today at 12 in Splash E, me and Alanin are actually presenting a paper that could also have been titled 12 Reasons You Didn't Know English is Actually Different from Other Natural Languages. Many things that English does, other languages do not. And all our parser frameworks are made on English. But so as I realized, I was getting so defensive, right? But it is hard. Trust me, I am smart. I am part of this community because I do hard things. Then I was thinking, what am I doing? Like, I seriously, I felt my soul leaving my body. I was like, because I'm leaning in to this perspective that in the PL community, to be important means to do hard things. This is what we believe. And if I explain why the things I'm doing are very hard, then I'm buying into this dominant perspective of we want to do things that are hard because, well, it's enjoyable. And also maybe it makes us feel really good about ourselves because we feel so smart. So just to show you how easy it is, yesterday night I have looked at the entire top 10 of all the TIOBE indexed programming languages, and the simple thing I tried to do was put Arabic numerals in. Do you want to see my results? This is C. It doesn't work. This is C++. It doesn't work. You get not one but 2 error messages. That's nice. This is Java. This is C#. This is JavaScript. This is Visual Basic. The build failed. Fix the build errors and run again. Thank you. Visual Basic. This is PHP. Undefined constant. It's nice. It takes the constant and then it assumes it is that string of that constant, but it doesn't do anything else. It will just throw an error. This is SQL. I had my hopes up for SQL because it's such a user-friendly language. No, it doesn't. And then this is assembly. It was actually quite hard to try to get the language in even. It doesn't work. So this is a paradox, right? And I think we can sort of look at this problem and conclude that it's not done not because it was too hard, but it's not done because it was too easy. Which is a problem, right? No one does this because it's easy. It is just different numerals. It is a simple change to your parser. But if it's so simple, why don't we fix this? And the most fun thing I saw this week was this badge. This is an actual splash badge. I'm just walking around. If you see this guy, say hi to him. But this is easy, right? This is just encoding. This is all very easy. But it is so easy that no one is working on these problems. Why? This is just very weird. So I would hope that in the future, if I say I work on localizing programming languages, people cease to say, why is this hard? Also to other people, specifically young faculty that are working on things that they care about, do not ask them why it's hard. Ask them why are you excited about this? Why is this a worthwhile cause? Who cares if it's hard, right? Because you are all like this, right? Well, it works on my machine. It works on my character set. But it's just very important. So I think the question that the PL community should start caring about more is not why are you doing this, but do you care enough about this specific topic to do the work? Also, if it is easy, and I trust you, again, we have a nice session at 12 in Splash E. It is not so very easy, but it also happens to be very important. So what I hope, if we're creating programming languages of the future, is that these programming languages will serve different perspectives. If you look at C++, whose perspective is in this language, right? Certainly not the non-Western perspective, because it doesn't allow for any of that. But maybe also not the female perspective. If you teach C++ to 18-year-olds in university, the female part of your students will have, for 10 years, been exposed to, hey, this is really hard. Are you sure you can do this? If that is your perspective, if this is your lived experience, like it is my lived experience, probably you wouldn't design a language like this, because it sort of drives the point home that programming is really hard and somewhat unreasonable, right? Because why do you have to do all these things to just print something? It also has a perspective of a certain ableism, because if you think about people that consume programming languages with a screen reader because they're blind, think of how this sounds like with a screen reader. It would be like std : : out, smaller than, quote, hello world, quote, semicolon. So it's also not made from the perspective of someone that's blind or visually impaired using a screen reader. And of course, it's not a problem that this language doesn't do this. But if you look at the TIOBE index, top 20, all the top 20 is made by male programmers. And only 2 are partly made by non-white programmers. So this perspective, there's nothing wrong with this perspective, but it's just the only perspective on building programming languages that we have is this male perspective of, oh, let's just try stuff out. It's this Western perspective of, wow, it works on my character set, which is just a perspective. But we really, really need different perspectives. And if you take a few seconds to look around in the room, look around you, right? This perspective is not here. And again, there are many reasons for this. Reasons are discriminations and role model, but this insistence that here we are doing things that are hard, and this is why we're doing that, just that is the dynamic of this community, is already excluding some people, probably more likely female participants who are more likely to care about like making the world a better place. Minority people that grow up in lower socioeconomic families are also more likely to care about making the world a better place and less likely of, how do I have fun on this planet? So thank you for listening to me. If you're interested in contributing to Hedy, if your native language is not in the 47 languages that we support, you can totally go to hedy.org/join and join as an open source contributor, or if you want to as a translator. We're always very happy to get new languages in.
So thank you, Felienne. There's some time for questions. So
you go first. Hi. So I wonder about like, do students ever get like inundated by levels, rules, and changing rules? And so there are like, I saw 70 levels, right? And
yes.
These levels has like different rules. Different constructs. Some constructs are kind of like throw away, like the echo and ask and stuff like that. And the semantics also change, like the string literal and not there. And so I mean, do they ever get inundated?
Yes, so they get confused in between levels. One answer to that is, but this also happens in math, for example, where in math, first subtraction cannot go below 0. So initially kids would learn 5 minus 3 is 2, but 3 minus 5 is 0. Because you cannot go below 0, and then you can go below 0. Or first you only do integer division, and then you add floating points. This is one answer. Another answer is that we're trying to do hard stuff with parsing, where we're trying to guess which level a line is, and then if you accidentally mix levels, then we know, oh, this is this level and this is the other level, so we can still run the program, but give you a warning that you're accidentally using a construct from a previous level. That doesn't always work, but in many cases that does work, and that is helpful as well, but also changing semantics is also part of learning in other fields. So this is frustrating, but it's not a frustration that we necessarily introduce. We basically take a model that's very common in other areas. It's a great question.
So earlier on in the talk, you started talking about bringing programming to the masses and how not everybody needs to be a programmer, they just need to have some programming ability. I'm confused with the goal of Hedy here, because you were basically making people programmers. Is Hedy also the solution for bringing programming to the masses? And if not, do you have opinions on that?
Yeah, it's a great question. I don't think necessarily Hedy is made for building programmers. I mean, the level of Python you're at the end is still like a small subset. It doesn't do OOP programming, for example. So I think more the goal of Hedy is to get your toe in the water. Oh, this is what programming is. Oh, I understand a few concepts now. So that if later you become, I don't know, a dentist or a hairdresser, then you recognize a little bit of programming. Or if you want to synthesize a script with an LLM, at least you have an understanding of the concepts. So that's also one answer. Another answer that the way Hedy is now is it's really geared towards kids. We very often get the question from adults, oh, could I also learn programming with Hedy? And then they can, I'm like, yeah, it's free, go ahead. But then the exercises and the way everything is laid out is very much aimed at kids because, well, you can't do everything, and kids are actually more enjoyable to work with than adults. So that's what we focus on now. But the techniques, of course, could easily also be used for end-user programming.
Thank you. Loved your talk. So I gave a talk at the doctoral symposium yesterday, and I'm already regretting some of my advice because I told the students, when you give a talk on your work, you should explain why it is hard.
Yeah. Well, this is the community that we created.
This
so
is the
I don't think it's
community we
bad
created.
advice.
So, and there were other parts of my talk in which I talked about some of these contradictions between our ideals of our research and the reality of what actually happens when CVs get looked at and so on. But I just wanted to get maybe a little more of your ideas on what should we be doing as a community. I mean, I think we talk about novelty, but we mean hard. Is it enough to just say no, novel doesn't mean hard, or how do we change this in program committees and?
Yeah, that's really, changing a community is really hard. So one thing really where you can go from two ways. Like one way we can do is just in conversations we have in the hallway, which is very powerful. And another way is to have something in the steering committee or in the program committees where there's a track maybe about real world impact, where we take a paper, our own paper or someone else's paper, and we just implement it in a context with users, right? Or show some real world impact. Usually if we want to do so, if we want to value something more, we do a track. Like it used to be really, really hard to get academic brownie points for programming, and then we say, oh, we have an artifact track where you can build something and you have a small paper and still it counts as a publication. So an impact track is maybe something you could do, but I think the biggest change is coming from the outside, where I don't know, I haven't asked many people, but my suspicion is many people like me that so much care about real world impact go to a PL community, to a conference or interact with people, and they think, okay, I don't see how my world values are aligned with this community. And as I say, I have these words now, I didn't have these words then. Like literally yesterday I was in a talk and people were joking about a Popple paper not having enough Greek symbols to be accepted. This is literally something that was said in this venue the other day. So I don't know.
Hi, thank you for the great talk. So one other place I've heard some similar ideas is very old. It's from it's the logo work of Seymour Papert, right? And so I thought it was similar because they targeted the same sort of audience of middle school children. They had many of the same concerns about inclusivity and girls and lower income students. And they had this, the turtle model, and you even had some slides with the turtles on it. So my question is, I guess, what's still relevant, and what ideas have you carried forward in Hedy, and what's different, and what does our modern computing environment give us a better ability to do?
Yeah, okay, so this will be the final question because my answer will be really long. My answer could be a 45-minute lecture, but I'll try to be brief. So this is a fantastic question because so much of the work in programming education has been informed by the logo created by Seymour Papert, and also Scratch, for example, comes from the same line of reasoning. What people tend to not know about the group of people that have created those tools, because we don't read the history of that, is that Seymour Papert was very, very much anti-school. If you read the first few pages of the Mindstorms book, he says in those first pages that he played with toy cars as a toddler, this is his words, and he learned more from playing with toy cars than in the whole of elementary school. This is literally in his book. And this perspective is in those programming languages. So Logo, but also Scratch, really, it's a tool for learning. It's a tool to teach yourself programming with, because you shouldn't need a teacher. I once wrote a paper about detecting code smells in Scratch programs, and the Scratch team, some people got really mad at me, because there cannot be a code smell in a Scratch program because whatever the child builds is correct, basically, was the idea, right? So those tools we don't really realize, but they are tools for building, and they don't take into account the reality of school, right? I would also like to live in a world where I have 3 students and sit next to them and say, what do you want to build? And then I will help you build what you care about, and I will help you care what you build, right? I would like to live in this world, but I live in the world in which governments around the world give teachers 30 kids, right? So then I cannot have tools that do not help me to manage classrooms. And specifically, Scratch is a tool that's not built for the classroom, because ultimately the people that build those tools think classrooms shouldn't exist in the most extreme form of their thinking. So they're just not made for reality. And I know some people say, well, you know, Felienne, then you're just leaning into how bad education is. You should also try to overthrow the system, which I sometimes do, right? I mean, you heard me speak. But in this case, I think if we want to help teachers manage classrooms, we need to have tools that are very, very simple and that allow for a lot of customization. And this is also what we just hear from people that use our tools. So in terms of programming language design, those ideas are still very valid. But in terms of editor design and the whole ideas of why are you doing this, they're just really in a different philosophical stream than I am. Oh, we do have time for one more question.
Well, yeah, I'm from Japan, and we have a pretty long history to develop our localized Japanese version of programming languages.
Yes.
So I totally understand. You know, I totally agree that localization of programming languages is so hard because we have more than 20, 30 years history. But unfortunately, those efforts are not successful from my viewpoint. And there are many reasons, because it's basically a difficult work. But one of the reasons I see is, you know, some kind of people do not like localized Japanese programming languages, because at school, now the government, also adults and some kind of people from industry say, hey, every Japanese kid should speak very fluent English, right? And now the programming language is also kind of mandatory language. Every kid has to learn. And that language has to be, well, in English.
Yeah.
So have you encountered such kind of pressure from the local government or adults or some people from industry?
Yes, this is also a great question. I'm really having fun. So one of the things we do in Hedy is we are a multilingual programming language. So if you program in Japan and your program parses, I can look at your program in Dutch, because you just take the parse tree and you print it with different keywords, which is very easy. And we're even working on a project now where we're also trying to, using machine translation, translate strings and variable names so you can really consume the program in your own language. So I do think that's one of the key things that make Hedy maybe more likely to be more successful, because you can look at programs from different natural languages, and ultimately it's Python just with a Japanese layer or a Dutch layer. But also one other answer that I'm seeing in interacting with teachers is, yes, this pressure that you talk about from governments, that exists, but also many people really, really want to speak in their own natural language. So for example, a few months ago, I was in Botswana, which is a bilingual country with English. So they're definitely not using Hedy because it's easier, because all their kids can do English. But the teachers are very excited to do Hedy in Botswana, because now they can show their students, look, our language that you don't want to speak because English is more cool, is also the language of technology. Look, you can use our language in the computer. You do not have to follow the imperialistic narrative that English is the world country, because this system allows you to bring programming close to you. So interestingly enough, many of our bigger user bases are in bilingual countries, the Netherlands, but also Indonesia, Puerto Rico, where many people speak English, but they don't want to. And then our system allows them not to learn programming necessarily in an easier way, but in a way that they want, that is close to their heart, which is also worth something.
Okay, let's go to the final question.
Okay.
Okay. So thanks for a great talk. I guess I was one of the people who asked why is that hard?
Sorry,
question.
man.
Sorry for that, but it
You
was
were,
quite eye-opening. So I have a similar question, which is that yes, it seems right that it makes sense to have these multi-language versions of educational languages. But you also talked about like the TOB indices and like the languages that are used in actual software engineering. And so, do you think that those languages also should be multilingual, or would that not? Like, it seems to me that would create problems with with people being able to understand each other when they collaborate across the globe, right? When we have code samples on Stack Overflow that you might want to copy and all those things.
Yes. Again, this is a great question. So of course, localization is also many things. Like just supporting different character sets for numbers is something that I think also professional languages could do. It's just easier also because of the ergonomics. Also quotes, right? So French doesn't use these quotes, but uses these quotes. Your parser is not going to use these GMS probably anywhere, right? So it's sort of, there's a few things you can do that don't cost you anything. That's one answer. One answer is there already are a lot of code bases that are localized, maybe not open source projects where people collaborate internationally, but in companies, if you're developing software in Dutch for the Dutch government or for Dutch companies, then the keywords might be in English, but the strings and the variable names and the comments are already going to be in Dutch. So in that, or Chinese or Japanese or Spanish. So in that context, maybe purely for the ergonomical reasons of not having to switch keyboards, maybe, then if you're already in this world, then it might be nice if your keyboards are also there. Of course, there is some tension that, yes, but then I will not be able to understand their code snippets on Stack Overflow, but then this question is almost always asked by, this is literally also in my paper, is almost asked from a Western perspective, because people that do not speak English or do not speak English well, they already live in this world where they do not understand code snippets on Stack Overflow, right? So this is just going to enable to them in an easier, better way to have maybe their own Stack Overflow. And also, one more thing, it is not hard to build a tool, if the code doesn't have a syntax error, to take it and to parse it and to output it in another programming language. And you all doing smart things about programming languages probably can also figure out a way to do something with something that has a syntax error, so it translates what it can just in time or something like that. So there's so many solutions, but the perspective of this question in the most mean way is like, yes, you are asking, but how can I still enjoy the free labor of other people solving my problems, right? And maybe other communities are also just served by communicating in their own language, and this is we already live partly in a world where not everyone can easily read Stack Overflow questions.
Okay, thank you, Felienne, for a great keynote. Let's have some coffee after a big round of applause for Felienne.